The binomial theorem, expanding binomials. Before we start, let's review how to evaluate NCR form. For C0, for example, using your calculator, press 4, then shift, then the division button, then 0, then equal, which will give you 1. How about you pause the video and give it a try with 4C3 and 5C2, for example. Now, let's look at the binomial theorem. As it appears to you, it is always a bracket with two terms inside, and it is raised to a power which can be any positive integer like 2, 3, 4, 5, 6, and so on. A here represents the first term and B represents the second term. By looking at the expansion, you can see that all terms are in a similar format. Each term has NCR multiplied by the first term raised to a power multiplied by the second term raised to a power. Doing more examples will help you understand better. Consider x plus y all to the power of 4. Since n equals 4, we start with 4c0 times the first term x raised to a power 4 times the second term y raised to a power 0. Then plus 4c1 times the first term x raised to a power 3 times the second term y raised to a power 1. Then plus 4c2 times the first term x raised to a power 2 times the second term y raised to a power 2. Then plus 4c3 times the first term x raised to a power 1 times the second term y raised to a power 3. Then plus 4c4 times the first term x raised to a power 0, then times the second term y raised to a power 4, then stop. As you can see, we started with 4c0, then 4c1, then 4c2, then 4c3, and finally 4c4. Also, we started with the first term x to the power 4, x to the power 3, then x to the power 2, then x to the power 1, then finally x to the power 0. Similarly, we started with the second term, y to the power of 0, then y to the power of 1, then y to the power of 2, then y to the power of 3, and finally y to the power of 4. Now we start simplifying using a calculator to evaluate each term, as you can see now. That would give the final answer as this. Looking at another example like x minus y to the power of 5. Since n equals 5, we should start with 5c0, then 5c1, then 5c2, then 5c3, then 5c4, and finally 5c5. The first term is again x. We start with x to the power of 5, then x to the power of 4, then x to the power of 3, then x to the power of 2, then x to the power of 1, and finally x to the power of 0. But here the second term is negative y. We start with negative y to the power of 0, then negative y to the power of 1, then negative y to the power of 2, then negative y to the power of 3, then negative y to the power of 4, and finally negative y to the power of 5. And again, let's use a calculator to simplify, as you can see. And that would give the final answer as. One more example like 2x minus 3y to the power of 4. Since n equals 4, we should start with 4c0, then 4c1, then 4c2, then 4c3, and finally 4c4. Here is the first term is 2x. We start with 2x to the power of 4, then 2x to the power of 3, then 2x to the power of 2, then 2x to the power of 1, and finally 2x to the power of 0. And the second term here is negative 3y. We start with negative 3y to the power of 0, then negative 3y to the power of 1, then negative 3y to the power of 2, then negative 3y to the power of 3, and finally negative 3y to the power of 4. Again, we start with simplifying using calculator, as you can see. Putting all them together will appear like this. Multiplying each term and write the final answer as this. Thank you.